Okay, guys, so we're back with another Java. Okay. So I was about here, right? Two dimensional. Was I done with it? No, I don't think so. Quickly, I think that's about right. Okay. So when you run this program, you will get okay. So this is another way of declaring a matrix, right? So you can do that. Declare an array within an array. As you can see, each row in the array is initialized. Should this be a little more close? Is this better? I don't think this is better. Yeah, this is right. So, as you can see, each row in array is initialized as specified in the initialization list. Let's look at one more example that uses a multi-dimensional array. The following programs a 3 by 4 by 5 3D array. Oh my god. It then loads each element with the product of its indices. Finally, it displays these products. Okay, so 3 by 4 by 5. So for I less than 3, 3D product of these, and then we display each. Okay, let me quickly do that. So we'll go here. Java, GitHub. Okay. So I was on arrays. Then let me make a matrix to show array initialization. Okay, so we'll have demonstrating list initialization, right? This is called a list initialization. Initialization. So we have class matrix. If I can spell matrix. Then we int, what is the name? Okay, so we have double M. We have double M equals to new double. I think it was a 4 by 4 matrix, right? Okay, so I can list initialize it. So first we will have our 0 times 0. Oh, 0 times 0 comma 0 0 times comma 1 times 0 comma 2 times 0 comma 3 times 0. Then we add a comma and then we create okay, whatever. So then we have 0 times 1, 0 times 1, 1 times 1, 1 times 2, 1 times 3. I think I should add commas here too. Then we will add this. Okay, then we have 0 times 2, 1 times 2, 2 times 2, 3 times 2, sorry, 2 times 3, then another comma, and then finally 0 times 3, that is the fourth row, times 3, 1 times 3, 2 times 3, and 3 times 3, and that's it. So now I can go ahead and display it. So I'll go for int I equals 0, I less than 4, I plus plus, and then for okay, I'm always going to add j equals 0, j less than 4, and j plus plus. Then we can just go ahead and print them out. Okay, print let's say double I and j, not double, sorry, that is the data type, m, and then we print a new line here. Okay, that it, right? Then I can go ahead and compile. And then I can call this, right? Yeah. Then another program, I will also be writing this 3D program. So let's close all unchanged. Then let's write this the 3D matrix. So 3D matrix.java. To demonstrate a three-dimensional array. Okay, so we have class 3D matrix, and I create a int 3D, right? 3D equals new int, it's 3, 4, and 5. Okay, then we will have int I, j, and k, and for I equals 0, I less than 3, and I plus plus. See, now this is better. Then for k equals 0, k less than 5, and k plus plus, I can go 3D of I, j, and k equals I times j times k. Then we can print it with the same logic. Yeah, print line and then print line, right? Okay, Okay, so we go system.out.print this, then we will print a new line just after this. Dot out dot print line, and then another line here for this for. Okay, so let's compile it, and it will just run. Right, so back to here. Okay, so we got the same output. Now we are talking about alternate array declaration syntax. Okay. There is a second form that may be used to declare an array, and this is this. Here the square brackets follow the type specifier and not the name of the array variable. Okay, so right, we can provide the square brackets before, and it helps in declaring. Okay, this alternative form offers convenience when declaring several okay, this declares create 3 arrays, and this also creates 3 arrays. Okay, the alternative declaration form is also useful when specifying an array as a return type for a method. Okay, this is important. Okay, now we are talking about introducing type inference with local variables. Okay, recently an exciting feature called local variable type inference was added to Java. To begin, let's review 2 important aspects of variable. First, all variables in Java must be declared prior to their use. Okay. Second, a variable can be initialized with a value when it is declared. Right. Furthermore, when a variable is initialized, the type of the initializer must be the same or convertible to the declared type of the variable. Right. No narrowing or widening. Thus, in principle, it would not. Thus, in principle, it would not be necessary to specify an explicit type for an initialized variable because it could be inferred by the type of its initializer. Right. Of course, in the past, such inference was not supported, and all variables required an explicitly declared type, whether they were initialized or not. Today, that situation has changed. Okay. Beginning with JDK 10, it is now possible to let the compiler infer the type of a local variable based on the type of its initializer, thus avoiding the need to explicitly specify the type. Okay. Local variable type inference offers a number of advantages. For example, it can streamline code by eliminating the need to redundantly specify a variable's types when it can be inferred from its initializer. It can simplify declarations in cases in which the type name is quite lengthy, such as the case with some class names. It can also be helpful when a type is difficult to discern or cannot be denoted. Example of a type that cannot be denoted is the type anonymous. Okay. Furthermore, And we move on to further. Furthermore, local variable type inference has become a common part of the contemporary programming environment. Its inclusion in Java helps keep Java up to date with evolving trends in language design. To support local variable type inference, the context sensitive identifier var was added to Java as a reserved type name. Okay. To use local variable type inference, the variable must be declared with var as a type name and it must include an initializer. Okay. Which initialize, but now using type inference you can just go var. Okay. So in both cases average will be of type double. In the first case its type is explicitly specified. In the second its type is inferred as double because of its initializer is type of double. As mentioned, var was added as a context sensitive identifier. When it is used as the type name in the context of a local variable declaration, it tells the compiler to use type inference to determine the type of the variable being declared based on the type of its initializer. Thus, when used in most places, var is simply a user-defined identifier with no special meaning. Okay. Thus, in a local variable declaration, var is a placeholder for the actual inferred type. However, when used in most other places, var is simply a user-defined identifier with no special meaning. Okay. So in this case, var is simply a user-defined identifier, and you can use that. In this case, the type is explicitly identified as int, and var is the name of the variable being declared. Even though it is a context-sensitive identifier, there are few places in which use of var is illegal. It cannot be used as the name of a class. Okay. Okay, so it is context sensitive. Oh, the context is. The following program puts the preceding discussion into action. Okay, var demo. So I should go var with var demo, right? Then we have something about strings, and then I will be okay. So let me quickly type the var demo. A simple demonstration of local variable type inference. We have class var demo. Public static void main string args. Then we use type inference to determine the type of the variable named average. In this case, double is inferred. Variable named average. In this case, double is inferred. So So we go where average equals gen dot 0. System dot out dot print line value of average and then we have in the following context where is not a predefined identifier, it is simply a user defined variable name. Okay, so the following context where is not a predefined identifier, where is not a predefined identifier, a defined variable name. So we have int var equals 1. Wait for a second. Okay guys, we're back. So we have this print line value of var, value of var, then interestingly in the following sequence, the following sequence where is used as both the type as both the type of the declaration of the declaration. Okay, there's a declaration and as a variable name in the initializer. So we go var k equals negative of var. So system dot out dot print line value of k, value of k. Okay, let's see this. Java var demo dot java. Right. Okay. Back to the book. Okay. So the preceding example uses var to declare only simple variables, but you can also use var to declare an array. Okay. Notice that neither var nor my array has brackets. Instead, the type of my array is inferred to be int square brackets. Okay. Furthermore, you cannot use brackets on the left side of the var declaration. Okay. Thus, both of these declarations are invalid. In the first line, an attempt is made to bracket var. The second attempt is made to because var equals to and which is this is the type. In both cases, the use of brackets is wrong because the type is inferred from the type of the initializer. It is important to emphasize that var can be used to declare a variable only when that variable is initialized. For example, the following statement is okay. So initialization is hold up. Okay, also remember that var can be used only to declare local variables. It cannot be used when declaring instance variables, parameters, or return types. Okay, so only local type inference. Although the preceding discussion and example have introduced the basics of local variable type inference, they haven't shown its full power. As you will see in chapter 7, local variable type inference is especially effective in shortening declarations that involve long class names. It can also be used with generic types and in a try with resource statement and with a for loop. Okay, so then we move on to some var restrictions. In addition to those mentioned in the preceding discussions, several other restrictions apply to the use of var. Only one variable can be declared at a time. Okay, only one. A variable cannot use you cannot use null as an initializer, and a variable being declared cannot be used by the initializer. Okay. A variable being declared cannot be used by the initializer expression. Okay. Although you can declare an array type by using var, you cannot use var with an array initializer. Okay. Array. As mentioned earlier, var cannot be used as the name of a class. It also cannot be used as the name of a reference type, including an interface, enumeration, or annotation, or as the name of a generic type parameter, all of which are described later in this book. Okay. Reference type including an interface, enumeration, or annotation, or the name of a generic type parameter, which are described later in this book. Here are two other restrictions that relate to Java features described in subsequent chapter but mentioned here in the interest of the completeness. Local variable type inference cannot be used to declare the exception type caught by a catch statement. Also, neither lambda expression nor method reference can be used as initializers. Okay. Then we have a note. At the time of this writing, local variable type inference is quite new, and many readers of this book will be using Java environments that don't support it. So that as many of the code examples as possible will compile and run for all readers, local variable type inference will not be used by most of the programs in the remainder of this edition of the book. Using the full declaration syntax also makes it very clear at a glance what type of variable is being created, which is important for the example code. Of course, going forward, you should consider the use of local variable type inference where appropriate in your own code. Then we have a few words about string. As you may have noticed, in the preceding discussions of data types and arrays, there has been no mention of string or string data type. This is not because Java does not support such a type, it does. It is just that Java's string type, called string, is not a primitive. nor is it simply an array of characters. Rather, string defines an object, and a full description of it requires an understanding of several object-related features. Okay. As such, it will be covered later in this book. After after objects are described, then however, so that you can use simple string in example. The following brief introduction is in order. The string type is used to declare string variables. The string type is used to declare string variables. You can also declare array of strings. A quoted string constant can be assigned to a string variable. A variable of type string can be assigned to another variable of type string. Okay. You can use an object of type string as an argument to println. Okay. Here str is an object of type string. It is assigned this is the test, the string displayed println statement. As you will see later, string object may have many special features and attributes that make them quite powerful and easy to use. However, for the next few chapters you will be using them only in the simplest form. Okay, then we move on to chapter 4, operators. Java provides a rich operator environment. Java provides a rich operator environment. Most of its operators can be divided into following 4: arithmetic, bitwise, relational, and logical. Okay. Java also defines some additional operators that handle certain special situations. This chapter describes all Java's operator except for the type comparison operator instance of, which is examined in chapter 13, and the arrow operator, which is described in chapter 15. Okay. The arithmetic operators. Arithmetic operators are used in mathematical expressions in the same way that they are used in algebra. Okay. The following we have addition, subtraction, then multiplication, then division, modulus, increment, addition assignment, subtraction assignment, addition assignment, subtraction assignment, multiplication assignment, division assignment, and then modulus assignment, decrement. The operand of the arithmetic operator must be of a numeric type. You cannot use them on Boolean types, but you can use them on char types, since char type in Java is essentially a subset of int. Okay. Then we have the basic arithmetic operators. The basic arithmetic operations, addition, subtraction, multiplication, and division, all behave as you would expect for all numeric types. The unary minus operator negates a single operand. The unary plus operand simply returns the value. The unary plus operator simply returns the value of its operand. Remember that when the division operator is applied to an integer, there will be no fractional component attached to the result, obviously. The following simple program demonstrates the arithmetic operators. It also illustrates the difference between floating point division and integer. So let's take a look. We have this basic math, then we go a plus, multiplication, division, and a unary negative. Arithmetic doubles. Okay. Alright. Then you have the modulus operator. The modulus operator percentage returns the remainder of a division operation. Yes, I know that. It can be applied to floating point. It can be applied to floating point types as well as integer. Okay. We have this x. So we go x mod 10 and then this 40 25. Okay. Then we get to arithmetic compound assignment operator. Okay, so arithmetic compound assignment operators. Java provides special operators that can be used to combine an arithmetic operation with an assignment. As you probably know, statements like the following are quite common. A equals a plus 4. In Java, you can rewrite the statement as shown here. A plus equals to 4. Okay. So the version this version uses the plus equal to combined assignment operator. Both statement performs the same action. They increase the value of a by 4, which can be expressed as this. Okay. In the case, obtains the remainder of a divided by 2 and puts the result back into a. Okay. There are compound assignment operators for all of the arithmetic binary operators. Arithmetic binary. Okay, there are compound for all of the arithmetic binary operators. Okay, thus any statement of the form this form variable equals variable operand operation then expression can be rewritten as this. The compound assignment operators provides two benefits. First, they save you a bit of typing because they are shorthand for the equivalent long forms. Second, in some cases they are more efficient than their equivalent long forms. For these reasons, you will often see compound assignment operators used in professionally written Java programs. Here's a simple program that shows several operation equal to assignment in action. Okay, so I should type this out, right? Yeah. Okay, so let's go. And op equals dot java so sorry, my bad. Let me remove this. Yeah, and I want to remove any class files. Let me see. Let's get okay, now I want chapter 4, which is with operators. Okay. Let's create a new directory. Operators and then ct2 operators, and then let's create arithmetic operators. Arithmetic operators. I don't know if I'm right. arithmetic. Okay, arithmetic. Then I want to create new file called op equals dot java. Then I want to open it here. No. Okay, so I have this. Demonstrate several assignment operators. Several assignment operators. So we have class op equals then we call some we have int a equals 1, int b equals 2, and int c equals 3. So let's try a plus equals 5, so that's 6. Then b times equals 4, so 2 into 4, that's 8. And then c plus equals a times b. So we have an expression. First we'll do a times b, which is say 8, and this is 8, 64, and c is 3. 3 plus 64 is 67. And then c modulus 6, 67, 66. I'll get a remainder 1. Right. Oh, a is 6. Oh yeah, sorry, 6. So sorry. So 6 8s are 48, and then 48 6. Oh, and 3 48. Yeah, it should be 3. Right. Okay. Because 48 plus 3 is 51. By 6 we'll get a 3. Line a equals plus a b and then we'll go with c and c. Right. Okay, so back to the book. Right, then we move on to increment and decrement. The plus plus and minus minus are Java's increment and decrement operators. They were introduced in chapter 2. Here they will be discussed in detail. As you will see, they have some special properties that can make them quite strong. Let's begin by reviewing precisely what the increment and decrement operators do. The increment operators increase its operand by 1. The decrement operator decreases its operand by 1. For example, x equals x plus 1 can be rewritten as x plus plus, and similarly x equals x minus 1 can be rewritten as x minus minus. Okay, so these operators are quite unique in that they can appear both in postfix form, where they follow the operand just as shown, and prefix form, where they precede the operand. Okay. In the foregoing example, there is no difference between the prefix and postfix forms. However, when the increment and or decrement operators are part of a larger expression, then a subtle yet powerful difference between these two forms appear. In the prefix form, the operand is incremented or decremented before the value is obtained. Yes. obtained for the use in the expression. In the postfix form, the previous value is obtained for the use in the expression and then the operand is modified. Okay. So x equals 42, then y equals plus x. That means y has value. First we will increment x to 42 to 43, then so y is 43. In this case y is set to 43 as you would expect, because the increment operator occurs before x is assigned to y. Thus y plus plus is the equivalent of these two statements, x equals x plus 1 and y equals x. However, when written this, then y is also 42 and then x is incremented after. Okay. Right. Then we have the following program demonstrates the increment operator. Right. Okay, I'll quickly write this, then we will do bitwise operators next time. Okay. We have increment and decrement. My bad. Okay, so increment, decrement. Okay. Demonstrate plus inc then int c is undeclared and int t is undeclared. So we have c plus c equals plus b, therefore c has value 3. D equals a plus, therefore now b is 3 and d is 1 and a is 2. Okay. And finally c plus, so therefore we get c is 4. System.out.println a equals plus a, b c d d c b. There we go. Let me get rid of all classifiers and we call it a day.